So as I mentioned, even though Black Death gets a lot of attention, obviously because it killed so many, the Little Ice Age was full of other diseases, pestilences, outbreaks, etc. I just wanted to show one little one, not a little one. In medieval times, outbreaks of St. Anthony's fire were common in populations subsisting on rye bread. Ergot poisoning caused gangrene and burning pain in extremities, convulsions, hallucinations, and severe psychosis. Death often followed. Sometimes entire village populations were afflicted with visions, and pregnant women often miscarried. During the Great Famine, outbreak of ergot poisoning were common. There is a word ergo which means something else, but I don't know whether this is pronounced ergot or ergo, but there we are. I should have looked it up. But the other point I want to make before I should have flipped these slides, but the plague that we talked about did go on for multiple centuries, as we saw. The Great Plague of 1665 had a severe impact on London as well. Coming back to St. Anthony's fire, the tragic illness that plagued history, so that's the kind of artistic rendition of what was happening. So the description is crazy enough. So the fungus that would infect rye would get through the rye bread into people who consumed it and create these problems that we talked about. The so-called dancing plagues of Europe are perhaps one of history's strongest footnotes. According to the Lancet, the famous health journal, sorry, I'm having a hiccup. The first incident of mass hysteria characterized by uncontrollable dancing seized 18 people in 1021. It was said that they danced for a while before regaining control of their bodies, and while that seems unlikely, that's not the only story. Okay, so there were typhus, as we said, all tuberculosis, and a plague, and St. Anthony's fire. Returning to Ice Age, yearly distribution of 6,929 documented bubonic plague outbreaks in the greater European region during 1347 to 1900. That's multiple centuries, but you can see the peaks there. Local frequency ranged from one outbreak in 544 locations to 146 outbreaks in London. So time is going here from 1350 to 1900. Even in the 20th and 21st century, we still have annual cases of plague in the tens, maybe a couple of hundred across the world. So plague outbreaks per year here. The Black Death obviously was a massive number here, 120, and then you had the 30-year period here of war, which again brought up plague, malnutrition, conflicts, soldiers bringing diseases, soldiers crowding together and creating infections and so on are always common. The Great Plague of London happened here. So plague, of course, was a big part of it. It's not just in Europe that Little Ice Age has had impact on conflicts and health and agricultural production and so on. China, this study in the Proceedings of the National Academies of Sciences in the US looked at a long period over China for flood epidemics, famines, droughts, locusts, temperatures, minima and maxima, and put together all the epidemics, and you can see the Little Ice Age period here has much higher concentrations of epidemics, assuming there are no data issues going back in time. But this study concludes that at least over China, colder temperatures led to more epidemics. Okay, so depends of course on what came with the colder temperatures, whether it was just perturbations to agricultural production, people migrations, migration of the mice, movement of the plague bacteria, and so on and so forth. But nonetheless, many conflicts also have been potentially associated with the Little Ice Age and the associated climatic impacts in the Chinese region as well. Okay, I will just leave it there. The other thing that happened during the Little Ice Age, during 1788 to I think almost 1793, there were multiple El Niños, which is referred to in this book as Super El Niño, even though the term Super El Niño is now used for events that are massive, like 97-98 and 2015-16 or 1982-83. There are even bigger ones in Holocene records that are inferred from corals and so on. So we haven't diligently gone through what El Nino is, and I won't do this here again because you can just look it up in the multiple podcasts that I have. But essentially, it's the biggest perturbation to sea surface temperature and atmospheric convection rainfall in this region, but because convection and rainfall in the atmosphere releases a lot of heat, there are global perturbations to temperature and rainfall. So these are El Nino conditions in the tropical Pacific which shift rainfall. So you can see there are different seasonalities because El Nino evolves over 6 to 9 months and demises over 3 to 6 months, so it can have a life cycle of longer than a year depending on how strong it is. So you can see that the region here, January to April, gets wet. The peak of the El Nino warming in the eastern Pacific, even though the warming can happen around the dateline as well, tends to happen during December, January, February. I should at least mention that the name El Nino means the child, the Christ child, because the Spaniards that colonized the western South American coastline saw that warm waters were coming up the coast during around Christmas time, and the cold, miserable temperatures were nicer for some time, and since it came around Christmas time, they thought it was a gift of God. They call it the child, or El Nino. The opposite phase, where it gets much colder than normal, obviously cannot be called anti-El Nino. It would be anti-Christ, so it's called La Nina, which we will see in the next slide. Okay, so wet anomalies here, January to April, and dry anomalies here. This is June to September, the main season of the monsoon. July to September here, you can imagine this is like the ITCZ, wet anomalies here and dry anomalies here. And this region gets severely dry because the convection that's here dumping a lot of rain shifts eastward, and you get excess rain, mudslides, and so on over here. Then there are changes in the ocean as well, with reduced upwelling or bringing up of nutrients which support phytoplankton, fish, biodiversity, seabirds, and so on disappear. A lot of fish die, fishing disappears, and so on. But on this side you get dry, so even US has many signals: wet here, dry there, November to following March, December to March, November to following April. And so you can see that the impacts can happen throughout the year. The opposite phase of La Nina brings not necessarily exactly opposite of the El Nino, but still has some opposite phases. So dry, wet, wet, a little bit of dry here, wet anomalies here, so floods and so on. Dry here, but you can see that when La Nina conditions persist here, these coasts get quite dry, which is what is happening in the western US at present, where you have the massive heat dome and record-breaking heat wave happening in June, July of 2021, as we are talking about this here. So you have other signatures here: wet during winter months and dry and warm during the fall to winter months, and so on. They have massive impact on health, on migrations, on civil conflicts, and so on. This is the example from the massive El Nino of 2015 to 16, which elevated the disease risks across. So hantavirus, plague, West Nile virus over here, chikungunya and dengue fever, malaria, chikungunya, which actually creates this temporary arthritis which can lock up your knees and make your life really miserable. Respiratory illnesses: cholera, malaria, Rift Valley, cholera, malaria, chikungunya, dengue, respiratory illnesses, and so on and so forth. There are also dust storms, meningitis, respiratory diseases, and so on and so forth. So the El Nino of 1788 to 1793 or so created massive problems, and one of the examples is famines over India in 1792, the so-called Madras presidency of the time. And you can see various regions of the presidency where the serious number of people died: 141,000, 185,000, 96,000, with smaller numbers in the middle. So this is what caused a lot of attention to famines over India, and later on by Sir Gilbert Walker, who ended up doing research and showing that the monsoon droughts and famines were related to the pressure oscillations in the Pacific between Darwin and Tahiti, and he related that and tried to make some predictions. Later on in the 1960s, we realized that what Walker called the southern oscillation of the pressure is essentially same as what we now call El Nino. So it's now together called El Nino Southern Oscillation, or ENSO. Okay. During that time, UK had some power, some empire, some military power, and so on, but it also had massive food problems, poverty, diseases, and then decided to ship out the convicts or criminals, and the so-called First Fleet arrived here. You can see this is 1788-89. So there was a ship accident here, or maybe disappeared while exploring the Pacific. United States gained independence from the British there, which caused financial problems as well. The Perouse came into New South Wales, and the First Fleet came in as well. And this was an El Nino. As we know from here, El Nino causes massive problems over Australia. Right? Here we are. So they were brought in at the worst time, and it was really full of diseases, food problems, conflicts, and pestilence, and so on and so forth. So again, climate-driven, exacerbated by crime problems, financial problems, loss of a colony, and so on and so forth. So again, climate is never the proximal cause, but can become a multiple stressor, or what is referred to as barbarian at the gate, to drive these kind of confounding factors, which ultimately lead to human casualties in terms of health issues. Okay. So we will leave the little Ice Age story there. It's rather short, but as I said, I'm not going to go into details about historic events that the book lists. I'm going to just extract everything, try to focus on just what can be directly related to health issues.